Hello everyone, welcome to Equal To, and this is episode 27 of our Polynomials playlist, and we have been solving questions from exercise 2.4. Right, in this video we are going to start with question number 11 of exercise 2.4, which is to factorize this polynomial. So factorize 27x cube plus y cube plus z cube minus 9xyz. Okay, so this is the question. Now, there is this identity which we have learnt a few videos back, okay, that involves x cube, y cube, z cube and this xyz term. I hope you remember that identity. If not, I'll write it now so you can remember it. Okay, the identity goes like x cube plus y cube plus z cube minus 3xyz, which is equal to x plus y plus z into x squared plus y squared plus z squared minus xy minus yz minus zx. This is that identity. Okay, now this is the identity that we are going to use to solve this factorized question. So let us first write this polynomial in terms of this x cube plus y cube plus z cube minus 3xyz, so that we can convert it into the RHS form, right? So let me just have this inside a box. It's just a separation layer. You can try to remember it. Okay, now this 27 is actually 3 cube, right? So 27x cube can be written as 3x the whole cube. And then y cube is just y the whole cube, and z cube is just z the whole cube, and minus 3xyz, right? So 3 into x here is 3x into y into z. Okay, now it is of the form x cube plus y cube plus z cube minus 3xyz. Okay, now you can just straight away convert it into the RHS side. So that is going to be x plus y plus z, right? So 3x plus y plus z multiplied by x squared. So that is going to be 3x the whole squared plus y squared. That is plainly going to be y squared and z squared minus xy, right? So 3xy, 3x into y minus yz minus zx, right? So minus 3xz or minus 3zx, anything is fine. Okay, so sorry, only one bracket is required. Okay, so this is your factorized form. You can further evaluate it by like squaring this 3x, so that can be done. So 3x plus y plus z multiplied by 9x squared plus y squared plus z squared minus 3xy minus yz minus 3xz. Okay, and that is your factorized form, and that is how you factorize this polynomial. You just have to know this identity: x cube plus y cube plus z cube minus 3xy is equal to x plus y plus z into x cube plus y cube plus z cube minus xy minus yz minus zx. Quite a long identity, but it has a format, so you can easily remember it. Okay, we have solved this factorized question. Moving over to the next question. This is very similar and it uses the same identity, but instead of factorizing, they want you to verify if x cube plus y cube plus z cube minus 3xyz is equal to half of x plus y plus z into x minus y the whole squared plus y minus z the whole squared plus z minus x the whole squared. Okay, you're supposed to verify this. Now generally, to verify something, you can either take the LHS and convert it into the RHS, or you can take the RHS and you can convert it into LHS. Now in this case, you're going to do the latter. So that you're going to take the RHS now. Let me first write the RHS here. So it's 1 by 2 into x plus y plus z into x minus y the whole square plus y minus z the whole square plus z minus x the whole square. Okay, so that is the RHS. Now what you're going to do is you're going to expand this x minus y the whole squared, y minus z the whole squared and z minus x the whole squared. So we have 1 by 2 x plus y plus z into x minus y the whole squared is x squared minus 2xy plus y squared, right? And then we have y minus z the whole squared, so that is y squared minus 2yz plus z squared, and then we have z minus x the whole squared, so that is z squared minus 2zx plus x squared. Okay, now you can group these terms. So 1 by 2 into x plus y plus z, and then we have 2x squared, right? One x squared is here and other x squared is here, one y squared is here and another y squared is here. We have one z squared here and another z squared there. Okay, so we are going to group them. So it's going to be 2x squared plus 2y squared plus 2z squared minus 2xy minus 2yz minus 2zx. Okay, so that is the term that we have. Now if you can see, let me just move this over. 1 by 2 into x plus y plus z, you have 2 in all the terms in this part, right? 2x squared, 2y squared, 2z squared minus 2xy minus 2yz minus 2zx. So we have 2 in all these terms, so you can take 2 as a common factor outside, so that leaves you with x squared plus y squared plus z squared minus, sorry, it's not 2 because we have taken the 2 outside, so it's minus xy minus yz minus zx. Okay, and this 2 and this 2, they can get cancelled, right? Now what we are left with is x plus y plus z into x squared plus y squared plus z squared minus xy minus yz minus zx, right? Now if you know, this is the very same identity that we used in the previous question. Okay, if you compare the RHS x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx, that is the very same thing that we have here. So since we have this, you can write this in that form, which is x cube plus y cube plus z cube minus 3xyz. Okay, and this is your LHS for this question, right? This is your LHS for this question. It's the very same thing, so you have verified it, hence verified. Okay, it's quite simple. You have just taken the RHS, you have expanded the identities there, and you have just tried to simplify it, and that comes out to be the identities RHS. So you have replaced it with your LHS, and that is the LHS of the question itself. Okay, nice and simple. Moving on to the next question here. Again, a simple question that uses the same identity, or maybe not the same identity, it just involves a certain tricks here. Okay, so observe this question very carefully. You have to remember certain things from this question to solve this. Okay, now we have been given that x plus y plus z is equal to 0. Okay, now what you can do is you can write this as x plus y equal to minus z, right? We have subtracted z on both sides, or you have taken this z to the other side, so x plus y is equal to minus z. Now what you are going to do is, we need cube terms, right? We need cube terms, x cube, y cube and z cube. So we are going to cube both sides. Okay. In this step you have subtracted z on both sides. In the next step you are going to cube both sides. Okay, so that is going to be x plus y the whole cube is equal to minus z the whole cube. So we know this identity x plus y the whole cube, so that is x cube plus y cube minus 3xy into plus 3xy. I'll just rewrite this again, it's not good looking. Plus 3xy into x plus y, and that is equal to minus z cube. Why just minus z cube? Because this sign remains the same when cubing a number. Okay, now what you're going to do is, from the question, from this thing that we have noted, we know that x plus y is equal to minus z, right? So you are going to use 1 here. When you use that, it becomes x cube plus y cube plus 3xy into x plus y is equal to minus z, right? So you are replacing this x plus y with minus z, and that is equal to minus z cube. Okay, now what has this term become? X cube plus y cube minus 3xyz, and that is equal to minus z cube. Now you are going to take this minus 3yx term to the other side and this z cube term to this side, or basically adding minus 3xyz and adding z cube on both sides. So what does that leave you with? X cube plus y cube plus z cube, that is equal to 3xyz. Okay, so you have proved that if x plus y plus z is equal to 0, then you can say that x cube plus y cube plus z cube is equal to 3xyz. Okay, so that is it for this question. We have solved 3 questions in this video. I hope you understood this. If you have any questions, any doubts, please feel free to put them in the comments. I'll get back to you as soon as possible. Thank you so much for watching this video. See you in the next video. Bye for now.